Hello guys, I'm Keetna here. In previous videos, I have talked about supervised machine learning and unsupervised machine learning. And in this video, I'd be talking more on advanced machine learning. Machine learning is a kind of very nurturing thing that we see today. Uh, it allows a computer to learn itself. It's like basically self-learning. So to model that, we need some techniques and algorithms that we are discussing on. And here are some important concepts of advanced machine learning. In advanced machine learning, I'll be talking on natural language processing. It's a very interesting topic, and I'll also talk on topic modeling and recommender systems. Let's move forward. The first concept is Introduction to NLP is an acronym of natural language processing. Why we need that? Because computers are likely to understand the structured form of data. They can understand the tables, spreadsheets, but it is very difficult to a computer to understand the human languages. Basically, they are of unstructured data, like they are text, voices, speech, these kind of categorical data. The machines are very difficult to understand. So here we need natural language processing. The natural language processing can be broadly defined as automatic manipulation of natural languages like speech and text by software. Natural language refers to the way that humans communicate with each other. Like they communicate through text, they communicate through speech. That is basically natural language. We can see that there are plenty of resources that are in the form of text, speech all over the internet and web search. We can see that. So to make the computers understand these kind of data, it makes the work easier so that we can communicate with the computer to make our work easier. And here are some applications of NLP. Question answering. Question answering is concerned with developing systems that can automatically respond to human questions in natural language. Like, for suppose we are seeing Alexa, Siri, and Google Assistant. These are like question answering. If we ask a question, then they reply a relevant answer. This is done by NLP. Information extraction is another application. Here we it is used to extract structured data from machine readable documents that are unstructured or semi structured, and we can also perform sentimental analysis. It is basically a tool that analyzes the sender's attitude, behavior, or emotional state. Like if we are responding to a post, if you are responding to a post, it can be positive, negative, neutral. That can be done by sentimental analysis. This tool can help the model to recommend the recommend the posts which are liked by the customer, the sender. So we do this kind of analysis, and there are many more applications of NLP. Moving on, how we do this process. Starting with, we are having a huge pairs of data. Now we have text data. Then we take that paragraphs of text, and we do sentence segmentation first. Sentence segmentation is that we break the piece of text in various sentences. We are having the paragraphs, then we take up to a sentence, we segment up to that. And the second step is to remove the punctuations. Punctuations are not required for us, so we remove all the punctuations so that the number of tokens, which are words, which are kind of words, gets reduced. So we remove the punctuations, and we don't want the stop words as well. Stop words are the words which do not infer any meaning to our text. such kind of words can be removed. And after that, what we do is we do the word tokenization, where we break the sentence into individual words. These words in NLP are called as tokens. We can tokenize them whenever we encounter a space in the sentence. And after we have a stemming and lemmatization that I will be talking on, and we remove the high frequency words too. High frequency words are the words which are seen in every sentence, which are seen, if they are seen in every sentence, it is uh, not likely that we get more information through that kind of words. What is stemming and lemmatization? They are both text normalization techniques, which are performed with NLTK package of Python. Stemming and lemmatization, both are they are for text normalization. Suppose if you are having same kind of words, like if you are having respond and responding, they are of similar words. So we can, if we are having such kind of words in many forms, then the number of words that we take as tokens gets increases. To limit that, we do this kind of process. This reduces the inflection in words to their root forms. And the basic difference of both of them is that in stemming, the words are mapped to the same stem, even if the stem is not valid. But in memotization, what happens is that we make ensure that the root word belongs to the language and it has some meaning in that language. We ensure that basically we want the lemmatization to be done, uh, but we can also do stemming if the data is very large. If the data is very large, then we try to do stemming because it takes more time in lemmatization process. This can slow down the model, so we can also go with stemming in such cases. And after that, topic modeling. This is a very another very interesting topic as well. In topic modeling, uh, what is topic modeling? If we are having a document, then we want to know what is happening. Then we do this topic modeling, which after doing the processing at the document level, one of the most useful ways to understand the text is by analyzing the topics it has. Like what are the topics it is having. If we know that, then we can infer what is the sentence or what is the paragraph talking about. Uh, this process of learning, recognizing, and extracting the topics across a collection of documents is called topic modeling. It is the task of identifying topics that best describes a set of documents. Topic modeling is a kind of clustering as well, an unsupervised machine learning process in which we come up with the meaningful theme across the list of documents. If you can see the picture here, here we are having many words, but here these words are grouped to linguists, which is a topic. And here we group it to religion. These words can be anything. This can be English. Some author can talk about linguist. Anything. So these all those words are mapped to a topic linguist. Like that, we map the words to a topic. In topic modeling, we have basically two assumptions which are really important. That each document consists of a mixture of topics, and each topic consists of collection of words. Yes, it's obvious that here, if you see, these are words, and these words are contained in a topic called here linguists. And these are coming from a document. This is completely a document, and from that we have a mixture of topics. Those are the basically two assumptions for topic modeling. And to do this kind of process, we follow a technique called latent Dirichlet allocation, which is a full form of LDA. First, what we do is we pre-process the data, where we use the count vectorizer to convert each string into numerical vector. We are having if we are having the data, and we first pre-process that. We use the count vectorizer to convert the each string into numerical vector. That the count vectorizer yields a n cross k document term matrix, where k is the number of distinct words across the n documents in our sample. Now what we do is we process the document term matrix by choosing an algorithm, and I said that already. Here we use the topic called LDA, and it's latent Dirichlet allocation. Why latent? That I will be talking on. Latent Dirichlet allocation. Latent Dirichlet is a generative probabilistic process which has a specific goal of uncovering latent topics in the text corpus. Like before, we have seen that here in this picture, these linguists, religion, interdisciplinary philosophy, these words come are not there before. They are very hidden. We discovered them. We discovered them through a process called LDA. And by doing a certain processing, we get those topics, and how LDA works. Uh, this is very mathematical concept as well. From We are having two Dirichlet distribution, alpha and beta. From the Dirichlet distribution alpha, we draw a random sample representing the topic distribution theta, and from the theta we take a topic, we take a particular topic called z, and this theta is taken from a particular document, and this beta is another Dirichlet distribution, from where we select the word distribution of z of pi, and this word distribution is pi, and from that pi we choose the word w, which is in the topic of z. This is the basic working of LDA. Uh, Previously, I said what Dirichlet distribution here, and what is that? It's similar to probability distribution, but in Dirichlet distribution, what happens is we don't sample from the space of real numbers. Instead, uh, it is sampling our probability simplex. Probability simplex is nothing but it's a bunch of words that add up to one. For example, if we are having an example here, you can see 0.2, 0.3, 0.5. If we add this bunch of numbers, we get a 1. We get 1. It represents the probability of three distinct categories, because we are having three numbers. If we want, it is of k distinct actually. If we can also have two numbers that add up to 1, like 0.7 and 0.3. If we are having, then it is the probability of two distinct categories. That is the concept of Dirichlet distribution. And moving on, introduction to recommender system. Recommender systems are that systems that whose objective is that we get the user get the recommendation of the relevant items of that user is based on their preferences. Like if the user has some preferences, then the recommended model, what it does is that it recommends the relevant items of that kind which that user has the preference of. For this recommender systems are popular because uh, it increases the market of many companies. Like if we take an example of Mintra, it recommends it recommends what we like instead of having what classically if it is having classical models. It doesn't recommend those traditional models. It recommends what we want. That kind of recommender systems are built today. And some the popular recommender systems are collaborative filtering, content based filtering, and hybrid approach. These are some of the mainly these are recommender systems. Collaborative filtering. This method makes automatic predictions. Uh, Predictions here nothing but filtering. It filter from many options. It filter out what we want about the interest of a user by collecting preferences or taste information from many users. That is collaborating here. It collaborates from many users, and it gives us what we are interested in. For example, uh, if we are having a person A who has the same opinion as person B, and we are having some set of items that the person A and B are having same opinion on, then the person A is more likely to have the opinion of person B for a given item that of a randomly chosen person. Yes, right? It's obvious, right? If two persons are having similar thoughts, and if we are giving another item which the other person has not seen, and the person A likes that, and it's more obvious that the person B also likes that than of picking up a randomly chosen person. In collaborative based filtering, we have two kinds of approaches: memory based approach and model based approach. In memory based approach, what is that? This approach uses memory of previous users' interactions to compute users' similarities based on items they have interacted. Users have interacted. That is user-based approach, or uh, the computed item similarities based on the users that have interacted with them. Like it is item-based approach. Based on a user-based approach or item-based approach, this of previous users, the memory is taken, and we do that. Or we can also do model-based approach. We use different machine learning algorithms to recommend items to users, like neural networks, like latent factor models like SVD and clustering. In memory-based approach, is good, but if we are having more number of users and more number of items list, it becomes complex. So we generally go with model based approach. Another type of filtering is content based filtering. In content based filtering, what we use is we use the person's previous data. This method uses only information about the description and attributes of the items the users has previously consumed to model the user preferences. In other words, we can say that these algorithms try to recommend items that are similar to those that a user liked in the past. In particular, various candidate items previously rated by the user, and the best matching items are recommended. We also have the hybrid approach, which is a mixture of collaborative filtering and content based filtering. This is a very popular approach now today, because we there are some disadvantages that are present for collaborative filtering and some disadvantages that we see in content based filtering. These both, when they get used in as a single model, then it becomes a very good recommender system. So we hybrid approach is one such thing, and that's all for this video. And if you would like to study more on LDA, then I would link a document which is a research document by Andrew, that you can see in the description box. And that's all for today. Thank you.